In general, we can solve problems involving sets by drawing a generic Venn diagram if there are 2 or 3 sets, identifying, if given, the numbers in the individual regions, assigning variables to the numbers in the remaining regions, and setting up and solving a system of equations. The important thing to remember is that English is hard, math is easy. The problem is we have many ways of stating something in English, but only one way to state something in mathematics. For example, a medical study on 3 risk factors A, B, and C requires 200 people with A, 200 with B, and 200 with C, 75 who only have A, 75 who only have B, and 75 who only have C. It also needs 125 people without any of the risk factors and 25 who have all 3. How many people are needed? We'll set up our generic Venn diagram with the sets A, B, and C. And first we know there are 125 people not in A, B, or C. And these are on the outside. And there are 25 people who have all 3, so these are in the intersection. While there are 200 people who have A, there's 4 possible locations for them in the Venn diagram. But the 75 who only have A must be in the region that does not overlap with B or C. Similarly, for the 75 who only have B and the 75 who only have C. Now, we don't know how many have A and C only, or B and C only, or A and B only, and importantly, we don't know that they're equal. So we need to assign 3 different variables to these amounts. So we know that there are 200 people each in A, B, and C. So in C, we have X plus Y plus 100, and that must be 200. In A, we have X plus Z plus 100, and that's also 200. And in B, we have Y plus Z plus 100, and that's also 200. And we can simplify these equations a little bit. And since there are 3 equations and 3 unknowns, we could solve for X, Y, and Z. So if we take our first 2 equations and subtract them, we'll eliminate X. And if we add our third equation, that will eliminate Z. And so we find. And we can substitute this value of Y into our first equation to get. And our value of X can be substituted into our second equation to get. And that accounts for everybody. So adding up all those numbers gives us. Now, while we could solve for X, Y, and Z, we don't actually need to. Note that the number of patients is 125 plus 75 plus X plus 25 plus Y plus 75 plus Z plus 75, or 375 plus X plus Y plus Z. So it's enough to find this sum X plus Y plus Z. And note that from our system of equations, if we add them all together, we get, and if we divide by 2, and so we know the sum of X, Y, and Z without actually needing to know what X, Y, and Z are individually, and so we can find the total number. We can consider another problem. Suppose 100 people are surveyed and we obtain the following results. How many liked none of the flavors? Note there are 4 sets, those who like chocolate, strawberry, vanilla, and durian. But we haven't drawn Venn diagrams for 4 sets. Well, remember, a problem exists whether or not we know how to solve it, so let's think about this. Note that the durian D set has no overlap with the others, so we can represent it as a 4th circle that doesn't overlap with the other 3. And we know the D circle has 11 people. Meanwhile, the intersection of C, V, and S has 2. Since there are 6 who like strawberry and vanilla, and part of that overlap has 2 people, the other part must have 4 people. Since there are 14 who like chocolate and vanilla, and part of the overlap has 2, there are 12 in the remainder. And likewise, there must be 3 in the remaining overlap between C and S. Since there are 52 people who like chocolate, and we've already included 17 of them, there must be 35 in the remaining portion. And since there are 27 who like vanilla, and we've already accounted for 18 of them, there are 9 in the remaining portion. And likewise, we must have 11 in the remaining part of the strawberry set. At this point, we've accounted for 87 people. And since there are 100 altogether, there must be 13 outside the 4 sets. And so there are 13 people who don't like any of the 4 flavors.